Hello friends, welcome to this video, and this video is a part of YouTube series Data Science and Machine Learning. Those who are interested in becoming a data scientist or who are already an expert in a data science and want to extend their knowledge, this YouTube series is for them. So friends, in a last video we have seen a, a by classifier, that means the classifier which can classify the two classes, and how that by classifier can be extended to make to have a multi-class classifier. Multi-class classifier means there will, if even if there are more than two, that means any 3 classes, 4 classes, or 10 classes, or 100 classes, the multi-class classifier will able to classify the data points. And then by class classifier can only be applied in a case where there are two classes, there are data points to be divided in a two classes only. Okay, so we have seen that how we can extend the by classifiers into multi-class classifiers, and then in this video we are going to implement those two methods, that means one versus one and one versus all. Okay, so the first we will focus on the one versus one. Okay, so let's start by this one, the data underscore classifier underscore multi underscore class underscore 01. Okay, and what we are doing here is we had a two classes. Normally we had a function which will generate the two classes, two clusters, two class clusters, whose centroids will be given as an argument, as an input argument to that function. So we generated this way the two classes data, and if we use the same function again but for the different cluster points, okay, we get a data 3 array, data 4 array. Okay, just like first time we got a data 1 array, data 2 array. That means the class 1 data, class 2 data, class 3 data, class 4 data, there mostly the centroids are the class 1 data has a centroid as a -4, 3, class 2 has a 3, -4, class 3 has a -4, -5, and class 2 has a 3, 4. Okay, and then there will be the variance, and because of that it will give a not all the points belong to one class will be at the same position, but the noise will be added to that to have a scattered one, a scattered cluster. Okay, so this way it's very easy to get a data for the four classes. Okay, only care you have to take is that the centroids. Okay, let's look at it, because we also have a plotting arrangement on the graph. So let me make this true, right, and let me run this, and let me extend this so that the graph can be visible, so you can see fairly and very clearly that one class, a second class, class 2 means green, class 3 class is a blue, and class 4 class is a triangles. Okay, the horizontal direction. Okay, so we have a data, and now for this class, so what we will do while explaining the program or while writing the program, we will consider the case of the four classes, but actually we are going to write the program for n classes. that means in general. Okay, so you just give a data of the 4 classes, or you give a data of the 7 classes. Okay, if you give a data of 7 classes, give a name also. Okay, and we are going to see how the name will be given. But yes, we will have to give a name. And even we have a, we take a 4 class data, we will have to give name to the each point, right, or each cluster. So you give any number of classes data, and this program should able to classify in a one of the one of them one of the those classes which are higher than 2. Okay, and not just the 2 classes now. Okay, so let me extend this data. So now I'm going to have a, because we already have a train data for of the 4 classes, okay, which is plotted here out here. Now let's start the training. Okay, and before training, I think we will need to have some training data preparation, because the data in this format is good for the plotting the graphs. And that's why, you know, what this function does, this function actually is in the classifier underscore utils. And what this function does, it gives a data of 2 clusters. But if we unfold the data from the one cluster, how it is going to be, it is giving like a x coordinates of all the samples are packed in one array, and then the y coordinates are packed in another array, and then both the arrays are packed in a one array. And and that is how it is becoming the graph graph friendly or plotting friendly. Okay, and that's why you can just have a 0 and then all x coordinates because of the 0, and 1 means y coordinates and of the all the samples, and you can plot. But that is not the case when we train the data, because we will need a data as a complete data as a one sample. So it will be like a sample after samples. Okay, in a graph it was a x coordinates after, and then after that the y coordinates complete, right, just for plotting. But now here the sample by sample we need the data, and that is why we have another function, okay, which will take a input as a data one array, and it will also take the class name to which this data one array belongs to. Okay, so let's see what this function does. And this function is again ut dot, and then ut dot means the classifier utils. So classifier utils is out here. Now in classifier utils, what we did, we have a data array to data labels we converted. Okay, so we just took a data array, and then labels were provided, data array was provided, but it was in the different structure. And now train data, and then we run a for loop. Okay, so this is these two lines are of the are actually the one line. Okay, so if I put here, I mean it will continue here. So what we did, train data dot append x comma y comma label. Okay, and for what, for x comma y in Jeep data array 0. Okay, all the x coordinates and all the y coordinates, okay, will have a same dimension, same length, and just zip them, and then you will get a x and y. So x coordinate from this and y coordinate from this, you will keep getting. Now once you get a x coordinate and y coordinate from these, what you do, you make a array of that, then you give a comma and then a label. Okay, so you have a label also. Now label is not an array, it's just a single, so it is going to be constant because this whole data array provided here is of a one class only, and that class is which that class is provided over here, that name is provided here, so it is going to be here. Okay, so this is called the tuple. Okay, you can see the notations are are different from the square brackets, right? So square bracket is normally a array or the list, right? Now here you got a, you know, these two things, the array of x comma y and label, are packed in tuple. Okay, and then this is the train data append method. Okay, so train data append method is actually appending the tuple. Okay, that means this train data is going to be array of the tuples, where each tuple has a first element as a array of xy and second element is a label, right? So then once that is done, I think the train data will go back here and we get a here. Okay, so earlier we made a train data label, right? The different structure than the data 1 array or data 2 array, and now this we are filling with the output of this function. Okay, so it will keep coming. Now one more difference here to consider or to figure out is the extend, not the append. Okay, now what this extend does, so let's consider it's not a extend. If it is append, what will happen? So we have a train data label and brackets. Okay, now we know this gives a array, this returns a one array, and let's say it could be a 20 points or it could be a 30 points. Let's consider that 20 points. Okay, 20 points, 20 elements, where each element is nothing but the tuple which has a x, y, and the second element is a label, right? So 20 points we get, and that is why if we use a, instead of extend, if we use a append, what will happen? This will have a, after execution of this instruction, this statement, the train data label will have a 20 samples, right? Then okay, and that samples will be nothing but the array. So the array of one array of 20 samples, and it will be appended here. Okay, so now this train data label will become a one array. Now let's say the same function, but now second class, data 2 array and class 2. Okay, so again it will give a list of, let's say 25. So this will become a 45 elements. No, sorry, it won't become 45 elements, because if we assume that this is the append, then earlier it was a 20 points array, so it got appended here. Now 25 points array, so it will be second array and it will get appended. That means array is getting appended to the array. And similarly, if the here also append and here also append, what will happen? The 4 arrays will be appended, and that will be in the train data label, right? So this train data label will have a 4 arrays, where the first array is of 20 points, second array is of 20 points, third array is again, so let's say 20 points, fourth array is also, let's say 20 points. Okay, but now if we assume, or now if we discard that assumption, and what is there, what is reality is, we are using a extend. So what will happen? It will take a 20 points and it will put in a train data labels after this. Now the second time, the second class data will come, and that 25 points, those 20 points earlier we had in this train data label, and now this 25 points will get appended to those 20 points. Okay, Earlier it was a, when it was a, it had a append, then it would have appended the already existing array of 20 points by a array of 25 points. But now 20 points are already there, and now these 25 points are getting appended to those 20 points and not the array of the 20 points. And that's where it will become a 45 points array now, single array. Okay, if it is append, then it would have been the two array of two arrays, right? Now again it will extend. So again 45 points are already there, 20 points already, 20 points will be given by this one, so it will become a 60 points now. Okay, so now 60 points will be in the one array, and now class 4 again will add 20 points, let's say. So because of this extend, it will become 85 points in one array. So there is a difference between the 85 points coming in a one array and another way, the four different arrays are coming into one array. Okay, so that's a difference between the append and extend. Fine, so let me go to the next step now. Okay, so I copied this now, I extended this program with this, and okay, so now the training is started. But before training starts, I think we will have to have a classifiers, the by class classifiers. Okay, because that's what the theory says. What the theory says, if it is a 1 versus 1, because right now we are focusing on 1 versus 1, and there are the 4 classes, then they are going to be 1 versus 2. And again let me remind you, 1 versus 2 classifier means it is a by class classifier, and it will take a one side, it will take a class 1 data, and another side it will take a class 2 data. Similarly, if it is a 2 versus 3, okay, if it is a 2 versus 3, if it is 2 versus 3, then this side it will have a class 2 data, and this side class 3 data. Okay, so that's what this notation says. So once we have a 4 class data, and we need to have a multi-class classifier for that, then we will have a 6 by class classifiers. Okay, and that's what we are going to generate out here. You can see first the train labels. Okay, we have just collecting the train labels, because now we have a data, this one train data label, okay, here available with the all the points means the points from the all the 4 classes, right? And so now the train labels a comma 1, okay, because we have already seen that when it adds a tuple, the tuple has a 2 elements, and the first element is a xy point, the array of the xy data, and the second element of that tuple is a label, and that's why second element can be accessed by index 1 and not by 0. The 0 is for the first element. Okay, so a of 1 for a in train data label. So whatever is in these train data labels, its a will be, that means tuple will be accessed, the a will be the tuple of that, and then the first element, that means second element by index 1 of this a tuple will be accessed and collected. So train labels, all train labels will come here. And if we give a np unique, okay, np unique of train labels, then it is going to be all the uniques. That means unique means, I think it will have these are the uniques one, class 1, class 2, class 3, class 4. Okay, and since we are writing this program for the generalize, so here if there are the 7 classes, automatically 7 classes will be assigned to the class names because of the unique one. Okay, because of this unique statement, right? Okay, so now you will have all these 4 classes here, and let us also run this. We have come here, and then now yeah, so you can see the train labels. Now see, data 1 array, data 2 array has a 40 points, 55 points, 40 points, and 55, and this 2 is because of the x and y. Okay, now it has been put placed in a 1. All these data 1, data 2, data 3, 4 have been placed in a train data label, and it has become a 190 because the sum of these length will be 190. And now if you want to see these data, you can see the tuples. I was calling the tuple, so this was a tuple. Okay, so this is the tuple of the 2 element size, and if you see that one tuple, then the first element is a array of xy coordinates, and the second is a label for that. Okay, so you can see these are all the 190 around, right? It is 190, yes, 190. Fine. So we got these train data labels. From that we got a train labels. Okay, so train labels, if you want to see, all these train labels are there, right? Class 2, class 3, class 4, and all. Okay, and then we get a enp unique. We got a class name, so must be class names here. And if you see, class 1, class 2, class 3, class 4. Okay, so we got that, and now our aim is to generate the all the possible combination of by class classifiers, and we start from, let's say, 0 to 3. Okay, so we have a 0, 1, 2, and 3. So CF will start from 0, 1, 2, 3, 4, so 0. And then for VCF, because for CF, because we have to generate the pairing here, right, which is the by classifier will have a one side class and the another side class. So those two classes pairing we need to find out here, and that's why this will generate the one side class, and this loop will generate the another side. So if it is a 0, then what will happen? The for VCF in range, again the num class, but here is a condition, VCF should be greater than CF. So if it is a 0, then for 0 it will start, but it will not work because 0 is not greater than the 0. Okay, then the VCF will become, next time it will become 1, and then yes, 1 is actually sorry, this 1 is actually greater than the 0 CF. Okay, and that's why it will come here and it will put a CF as a 0 and VCF as a 1. So you got a 0 versus 1. Okay, next time VCF will become 2. Okay, and 2 is greater than CF, that means which is 0. So here it will become a 0 and 2. So first one was a 0, 1, now second is a 0, 2, third one will become 0, 2, 0, 3. Okay, and now after 3 it will come here and it will make a 1. CF will become 1. When CF will become 1, so this will not run unless VCF becomes a 2, because it should be greater than the 1, which is CF. Okay, so for 0 and 1 VCF will not execute this, and when the VCF becomes a 2, it will be, this CF is 1 and it will be 2 here. Okay, so you can see, I think with this, see, it will not execute, and now it will execute. Now it has become a, we got a sub CF. So in a sub CF we will put a classifiers. So what is a sub CF? Where is a sub CF? Yes, so you can see 0 and 1 it has become. Okay, I'll come why we are taking a second side, why we are showing with the array. I'll just come in a minute on that. So you know, if you keep on going like this, okay, so 0. Okay, so the CF is equal to 0 is over, so we can see the sub CF is a 0, 1, 0, 2 and 0, 3. Okay, it has, okay, now it will go for the CF is equal to 1, and now it will not be VCF unless it becomes a 2. Yeah, now it has become 2, so it will go here and it will form. So 1 and 2. Okay, so it would have added 1 and 2. Okay, now it will add a 1 and 3 also. Okay, it has added 1 and 3, and now it will go out and CF will become 2, and now it will become a, unless VCF becomes a 3, it will not, because it should, VCF should be greater than CF and CF is equal to 2. So it has added, so now 2 and 3 it has added, and it will go up. So now we can see 2 and 3 it has added. Okay, and now I think it has done with the all. It will go for the CF is equal to 3, but there will be nothing higher than the CF, because CF range and VCF range is the same. So CF is the last element 3, so in VCF also last element is 3, so it will not execute that append one. Again it will come out, right? And then if we print out that, you got a 0 1 0 2 0 3 1 2 1 3 and 2 3. And now I will explain why I was taking a array, or I was using a array to to denote the second side of the biclassifier. And answer is over here. If you see here, when we are focusing on the 1 versus 1, yes, of course there was no need of that array actually on the second side, because 2 3 single are there. But I wanted to make a generalized, and even if we choose a OVA 1 versus all, that time you can see the second side there are the multiple classes. Okay, and that's the reason we are giving the second side, because the same kind of the notation we will be using for 1 versus all also. And that's why same function, I mean there will be the reusability of the function and very optimized way of writing the program, and that's why this is in the array. Okay, so now we will further extend this. Now okay, so we have designated the by-class classifiers. Designated means we have assigned the two side classes to the each of the by-class classifier, and that is been stored in this variable sub underscore CF. Okay, so sub classifier you can call. So and designated means we have given both the sides some classes allotted, okay, as appropriately. Okay, so now let me extend this. Now we will start, because you know we have a classifiers, and we know the classifiers with which classes they should be trained, right? Because if it is a this classifier, if it is a this classifier, that means the third one. Okay, this is a 0th one and this is the third one. So this classifier should be trained with the class 1 data and class 2 data. Okay, that's a different thing. The class 1 data means class 2 data will become, because in the category we have not written the class 0, we have started from the 1 2 3 4. Okay, so this one is nothing but the class 2. Okay, so class 2 on this side and class 3 on this side, and that's what the, okay, so we will use a class 2 data on this side and class 3 data on this side to train this third classifiers if we start from the 0th. Okay, so what we are going to do now, again, this is, we have a sub CF, so we will go for the each of them one by one. So let's pull out the one designated classifiers, and that designated classifier will have a one side class and say another side class. So a comma 0. Okay, so we'll come to that. Now we are taking a data from here, and what we are taking, again the same way, we are taking out the tuple from there in a for loop, and from for loop we are taking a 0th, and as I mentioned earlier, the 0th element, that means the first element of the tuple, 0th element, let's call it 0th element only. So the 0th element of that tuple is actually a data xy coordinates. Okay, and that's how it's coming. That's why it will come here, and we wanted that. Okay, so as a data A. Now the train data, but in a data A we have to take the data points which are belongs to the first side of the classifier. Now you know the classifier will have a two sides, right? The one side data and another side data, one side class and another side class. So let's call that A class and B class. Okay, so this first classifier, the SCF, we are taking, that means its first element will tell us about the data A, that means A side. So SCF 0, if you take a SCF 0, then whatever is written in that sub CF, okay, the whatever is written in the first element of the 0th element of the sub CF, it will come here, the SCF 0, and then it will be taken from the class names, right? So A1 will be the, because in a tuple we have allotted the class label for the each point, so that point will be taken here only when that belongs to this class. Okay, and this name is coming from the what the classifier, what the one side of the classifier is, or the what the first side of the classifier is, what the A side of the classifier is. Okay, and this is the data point label already there. Okay, if they both of them are matching, they will come in a data A. Similarly, data B. Now data B is, we have taken again in a array, right? Because but anyway there will be no use of array in this case, but still to have a common representation for the 1 versus 1 and 1 versus all, we have taken a second side of the classifier as a array, and that's why it will come here, and then it will take a, you know, here also it was taking a of 0, here also it is taking a of 0, but only when A of 1 is the B class. That means so B class is in the SCF, right, and it is a 1. Okay, in a data A it was a SCF 0. Okay, so this SCF, whatever the B class is there, it will come, and their class name will be picked up and will compared with the A of 1, and only the data A of 0 which has a label equals to the classifier's B side. Okay, the classifier's B side, that data will be picked up in a data B. Okay, so data B will keep coming here, right? And now that means now we have this first classifier, or one classifier from the sub CF, and its A side data and B side data has come in a data A under data underscore A and data underscore B. Okay, so that will be that data A, and that data B will be given to the by classifier, just to make a by classifier. Now you know, I think 1 or 2 videos earlier we have seen how we have already implemented the algorithm. If the data points from the two classes are given, we can calculate, we can determine algorithmically the hyperplane or hyperplane. Okay, and deciding hyperline is nothing but the deciding the slope of that slope of that line and the y-intercept of that line. So we will get a y-intercept and slope out here. But okay, let's go inside this by classified 2D, and you will feel very much familiar with the content of this function. So this is the classifier utils, and I think this is the by classified 2D. Okay, so this will give, this just takes a, you know, the two class datas. Okay, one class 1 data or class A side data and class B side data, and it will take a centroid, then calculate the midpoint of that, and then from that the slope of the centroid and hyperline, and then that's nothing but the we want to represent the hyperplane. Okay, so here we will get a y-intercept, here we got a slope of hyperline. right? So once we have a slope of hyperline and y-intercept, I think that's enough to decide the hyperplane, and that will be written. Along with these two things, we also doing the one more thing. We are calculating the average value of a one side class data's uh, that hyperline solutions. Okay, and then the sign of this val1, we are sending it along with the slope and y-intercept. Now why this is so, why this additional parameter and why these additional calculations, we are going to come on that very soon, but let me at this moment let me ignore that, and when the need arises, let me explain on that. Okay, so these three things will be returned, and we get a M and C and positive first, that means the sign one. Okay, I'll come to that, I'll explain that very soon. Now once we have a M and C and positive first, we are storing it. Okay, and now see, the first we had a array of classifiers in the sub CF, but it was only having a designated two classes, the one side class A name and class B name. Okay, but now it has a class A name, one side name, and another side class B name, and in it has already trained, so hyperline slope, hyperlines y-intercept, and also the first class, the class A sides, positive sign of the class A sides data. Okay, that's a positive first. I will be explaining it in detail, that one, right? So we got a sub CF train, so we got now sub classifiers also trained, and that has been stored in the this variable. Okay, now let me extend this, and what is the next test, because already the training is done, so next step will be the testing. So for the testing, we will have to have a data. We are not taking the data from the training data which was already generated, but we are generating the new data, and that new data is again generated with the same centroids, but the count is different. Okay, the count is different, and again, when we are generating with the same centroid, that doesn't mean this test data will be exactly or overlapping with the what was used, what data was used in the train. It is not like that, because the to the centroid points it is going to add a noise, and noise is a random, and because of the randomness what was added the earlier, the range of the noise will be same, but the exact noise magnitude will be different because of the random nature of that number generation. Okay, so and that is why there is a very less possibility that the data in a test will get exactly overlapped or exactly same same from the train data. Okay, it won't be, right? So so because it will be in a I mean it will have a different values than the train data, so there is a very high likely that it will have a different points. It will be in the same range, it will belong to the same cluster, but the exact value will not be as same as that in the train one, right? So now we generated this data, and this time we just for the testing we kept a 5 samples of all the 4 classes, so it's going to be 20 samples total, and then we put that data in a the classifier friendly. So we what we did, we had a xy coordinates as a 1 point in this, because that we have seen in the testing train while using the train data. So same way we just added whatever this data is generated as a test samples, so we have just put in the test data label. Okay, we extended again in the test data labels, and that's where we will have all the 20 samples of the test samples. Fine, now we are actually doing the testing. Okay, and testing will be nothing but will be as per the OVO, because this is right now we are focusing on the OVO. So let me remind you, we have all these classifiers, right? Just now we got them trained, right, in a sum underscore cf underscore train array. They are already there. And now what we are going to do, since there will be the 4 classes, we will have to have a array of the 4 classes where its scores will be 0 0 0 0, 4 zeros. Okay, and then we will use the data points for the first classifier, take a results and see where it belongs to, and accordingly increase the score. Okay, so that's what we are going to do in this step. And you know, at the final step of this procedure, we will get a this you know, the score matrix. We will get a score matrix with some values, and whichever has higher, that the corresponding class in which that data will belongs to. Okay, so let's go one by one. We have a test sample from the test data label, and now test data, that means the test data point, we extracted as a 0th element. As I mentioned earlier, we have seen earlier that it will have a tuple. In a tuple, the first or the 0th element will be the data point, and the first element will be the next element or the first element. This means 0th element will be the data point, so the first element will be a label, right? So that label, now label we are not going to use here, we will just use it for the verification or the validation purpose. Okay, so we know the result actually, but let our algorithm, one versus one algorithm, let that decide what the class it is predicting for this data. Okay, and then we will compare whether the predicted class is same as this test label or not. Okay, so we have a class score, np0's number of classes. Okay, so 0 0 0 0 will be there for 4 classes. Now let's take a from the sub cf trim, let's take a first sub classifier, right? And then sub classifiers is been given the cf. So first it will be given the test data, right? It will be given in the bracket because we have we are taking the list as a input. So even if the single data, but let's put it in the list. Now cf2, what is a cf2? That means this whatever is the sub cf train, this was the sub cf train. Okay, so 0th element is a first side data A side, class A side, class A name, class second next element, the 0th one, the first one is a class B name, and second one is a slope. So that's why we are giving a slope, we are giving a y-intercept, and it is a positive sign. Okay, okay, so now I think this is a right time to talk about this positive first. So okay, what will happen when we calculate the line equation? Okay, now if we so let me go back to this one, and maybe I think so let's consider this one. Okay, this point, this graph, this 2-dimensional. See what will happen whenever the data is given to us. For example, here we had been given a data of the red triangles and then green circles. Okay, but if you see there were the 2 types of the hyperline we had already come across, right? So one was a manually, and when it was a manually, I think I had chosen this one, right, that time. And when I chosen this one, we got a equation of that, and we tested all these points against this equation in the next slide, right? we got for the red points, when we solve on this hyperline, we got all the positives for the red points. For the green points, we were getting all the negatives, and that's how we differentiate. Whenever the next any test point comes, if it is a negative, that means it belongs to the green class, and if it is a positive, that means it belongs to the red class, right? For this equation. And that is why it is very important to write that for the red class, whether you are getting a positive or the negative points, negative values. Okay, you might think that no, always the first class we give is always a positives. No, we have a example in front of us when we did it with the using the machine learning, and we got this line, right? We got this kind of line. That time we again solve this equation, and you can see in both the cases they are separable. I mean, that line is able to separate the one class from the another class completely. But when we get this line, you can see when we solve the red points on for this line, we got a negative points, and for this line, for green points, we got a positive point. So there is a contradictions, and that is why it depends on whether we will get a positive or negative. It is depends on this line we calculate. And it is always, when we have a trend points, we can always test it. Okay, for these points we are getting negative, or for these points we are getting a output of this as a positive, or for this point we are getting a positive. So there will be always two possibilities, and it is better to check before in hand that whether these data, that side A gives a positive values, or side B gives a positive values. And that's why the positive first was a extra argument to add there, right? So sorry. So what we do there, we take all the points on from the one side. Okay, all the points from the one side, we take all the points from the one side and solve there, because these points are the trend. So we will already have these points with the labels. Okay, so this is called the red class, let's say. So this point will be solved here, and solved this, all values will be solved on this equation, and see, take an average of the whatever the values you get on this after solving this for all these points. Okay, and take an average of that. If most of them or all of them is negative, then it will be obviously the average value of the solution on this line for all these points will be negative. Okay, so that's a one possibility. And if it is a negative, then it is going to be a positive, right? So if it is going to negative, then negative it will be. The mean value of the solution of this line for all these points is a negative. Then this will be the positive first will be the minus. That means positive first will be assigned to this side. If positive first, that means if this is the positive first, actually that means the first side is positive, then positive first will be 1, otherwise it will be -1. -1 will indicate that positive first side is not positive, and positive first is equal to 1, then it means a first side or the class A is always positive. Okay, so I'm just repeating it again. These values, these data points, if solved for, let's say we have a 20 values, 20 data points, solved for this equation, we will get the 20 values, 20 solution values. Okay, and I take an average of that. If it comes negative, then positive first will be -1. If we solve, and then definitely this will have a negative, this will have a positive values. Okay, so that means, okay, we will see that. So if it is a, if all these values, it's second case, if all these values solve for this line and average them and got a positive, that means this is the positive first. The first class is a positive. Okay, so we are going to see that positive first is this or this. Okay, if the and if this is the positive, then we will say positive first is equal to 1. If this is a positive for these values are coming positive, that means it will come negative, so this will be positive first will be -1. Okay, see why this is, because now the next point is coming as a test. Now the test point will be solved for this line, and it will either give a minus or will give a positive. So let's consider if it has given a positive, then for the positive, okay, we are going to assign which class to that test point, this one or this one. So we should already know that for each class this line gives a negative and positives, and that has been stored in a positive first argument, and that's what the use of that. Okay, so we will see. So just to expand that, so we will have a 4 cases out here. What So these points are giving the solution of this line as a positive. Okay, and then we will have a test point. So test point gives a positive, test point is giving a positive value or negative value if solved for this line, right? So when this was a positive first, the test point is positive or negative. These are the two conditions. Second two conditions, second set of condition is this is not a positive first, so positive first is equal to -1. That means this was having a positive, this was having positive, that means positive second. Okay, second class is a positive, right? So in this case, whenever the test point comes, if it gives a positive or the negative, okay, so when it is a positive first is equal to -1, or it is a positive second, positive first is equal to -1 is nothing but a positive second, so that means second class is a positive. Okay, so that time then the test point comes, and then it will have it, there is a possibility that it will have a positive or the negative. So then it will belong to which category. If it is positive, to belong to which category, and if it is negative, which category, right? So it's a simple. If it is already positive first, and if the test point comes and test point solve for this line, if it is positive, if its value is positive, then it belongs to this. If that test point solve for this and then its value is coming negative, then it belongs to this. Okay, these two cases where of the when the positive first is true, that means 1. Okay, now suppose this is now another case, right? Another classifier where second class has a positive values and class first has a negative values, right? Then let the test point come, and if it is a positive, it belongs to this class 2. Okay, let the test point comes, and if it is solved and it is giving a negative values, then this is the class, that means it belongs to the first class. Okay, so that's what the real application of that extra argument in our program. Okay, so this will get returned, and this is calculated from here, right? We don't have to see the graph for that, we can do it over here only, right? And take a sign of that, and if the val1 is average of those, the class 1 side or class A side data values after solving on the lines are positives, then it will be the 1, because NP sign, whenever there is a positive value here, then it will give a 1. If it is a negative, it will give a -1. Okay, fine. So that's a flag, we are keeping it here. So now we have got a data, we got a test data, and we solved that value. So you can see this by classifier 2D predict. Okay, if it is in the classifier utilities, so you can see this data point will come. We have been already given m slope and y intercept and positive first sign, positive first flag, whether the positive is of the first class or the second class will be obtained from here. And now the data point, data array, because we have assumed that this is the list, so data point will come and then it will be solved on that equation, right, with the m and c and this. So y minus mx minus c is equal to 0, so that value will be, now this value will be compared whether it is a positive or negative, right? That means the test point values solved on that equation is positive or negative, and then even if it is a positive, then it will be checked whether the positive first is, for positive first is greater than 0, that means positive first is true or false. If it is a true, append 0 class. Okay, now we are enumerating those class A and B are like a 0 and 1. So class A means 0, okay, and class B means 1. We are just appending, right? So we will get a out, right? So in a out we will get a v to which class, whether the 0 or 1 class it belongs to, and 0 means the class A and 1 means the class B. So we will get it here, the out. And now this out, if now you now see the, you know, which is winning, because you have a one side class and another side class. So we have seen that if the 0th side class, that means whatever is in the whatever is written in a this CF0, you know, the CF one second, let me run this. Yeah, so it is a train only, so test we have put here, yes, it will stop here. And now you can see the test data is same, right? The class score is there, and now we have taken out the one classifier, the CF. So CF as a the first side has a 0 class, the second side has a class 1. Okay, so okay, so 0, so out, if it is a out is a 0, that means this class wins. Okay, 0th class, 0th class means what is the one. So in a class score, that first position will, 0th position will be incremented. So it depends on the that what is out. If the out is 0, then the CF side, that means CF0 side, okay, so CF0 side will, the scores will incremented by 1. And if out is a 1, that means the class B wins, and class B side we have only one class, what that class, in this case it is a 1. Okay, so the class 1, and not the class 1 but then first class we can say, because the class 1 here when we categorically write them, then it starts from the 1 2 3 4, so don't get confused here. So 0 0 and then here CF1, and now in a CF we have a, you know, array, and that's why A is taken out, and that will be now the length of the array, because you know in a one versus all, if there are the 3 classes on the other side, then it will be incremented by 0.33 0.33 0.33. It was because the 1 by 3 is equal to 0.33. okay, and that is why the length of CF. Now in this 1 versus 1, it is going to be 1 only, 1 by 1 is equal to 1 only, so it is going to be incremented by the ones only and by 1 only. Okay, but that will not be the case in the 1 versus all. We are going to see that after this. Let's focus on this. So we will get a, you know, it will either, so the out might be 0, and that's why it has incremented this side. So what is out? Yeah, out is 0, right? Okay, so you can see, and then I will just put this. Okay, so let us see one more one, and now you can see what was the out, again the 0 only, right? Okay, let us see again. Not necessary, always it is going to be 0. Okay, it is 0 again, no problem. Okay, this time it is not, it is 1. Out is 1. Okay, that means class B side wins, right? So like this it will go for all the 6, because it is a 4 classes, so we are going to have a 6 sub classifiers. So let me do this, and you can see the class score. Okay, according to the class score, elements will be incremented, and now if you see, the class score has reached to this one, 3012. So the 0th element is highest, so its score is highest, so this wins. So that means this belongs to class 0, not the class 0, the 0th class we will say. Okay, whenever the in terms of the indexes we have to say, then the 0th class or the first class or the second class, and when the category is a class 1, class 2, class 3, that will be the notation we will adopt for now. Okay, so this is the predicted class. Now test label has a already known ground truth, right? So it is taking a maximum of that. What is that maximum? Predict class, predict class, predict class. Okay, it has also already taken the class names and then NP argument, so it might be returning the 0, and then 0th class it will take. So what is that it is taking? What is that it is taking? What is that it is taking? Class 1. Okay, class underscore 1 it is taking, right? So, and then if it is equals to, then correct will increment, and then again the next one we will go, and now here again the second test sample, right? That is also going to be a first only, because the first 5 belongs to class 1. So if we repeat these for all the 20 samples, we will get after validation whether they are correct or not. As the sample comes, it will be counted here in a total, and as the sample is predicted correctly, then this will be incremented. Okay, so if I remove this debug point and if I continue, it will come here. Okay, and now it will print out the accuracy, right? So accuracy for 20 test sample is 100%. So okay, I think this was a very good separable classes on a plane. So and as and that's why we got a very good result, the 100%. But this will not be the case always. This will not be the case always. So we will see in the next video how to check the results for the data which has a more than 4 classes or 5 classes or 6 classes or even 3 classes. This was for the 4 classes, and we have written this code very generalized, that any number of classes data will be considered, will be processed by this algorithm and will give the output. Okay, so only the data need to be changed, the rest algorithm will remain same. So that's all for this video. Thank you for watching.